Thanks to Brilliant for supporting this SciShow video. As a SciShow viewer, you can keep building your STEM skills with a 30-day free trial and 20% off an annual premium subscription at brilliant.org/scishow. It's no secret that our planet is losing species to extinction every year. From pandas to porpoises, there are a lot of adorable animals in danger of disappearing from the wild entirely, but we are not giving up on them without a fight. Although it's not always the fight you would imagine. While researchers are focused on preventing extinctions out in the wild, some are working on a kind of backup plan that involves making brand new individuals via in vitro fertilization. But before they do that, they are increasing their chances of success down the line by figuring out how different species' sperm works and how effective today's sperm cryopreservation techniques are. They're testing how well sperm fertilize all kinds of eggs after thawing, and some of those tests result in dolphin-cow hybrids. So just let that idea sit with you for a second. To save other animals from extinction, researchers are putting the sperm of a dolphin together with the egg of a cow. At least part of the goal is figuring out how to preserve the endangered animal's sperm so they stay viable as long as possible, since those sperm samples are a pretty finite resource. And if you think the sperm of endangered animals are hard to come by, egg cells are even rarer, at least when it comes to mammals. Since most mammals don't lay eggs, there isn't any non-invasive way to harvest their egg cells, so we have a relatively small number of them to study. And that's why researchers are testing sperm that's closely related to their target species and combining them with egg cells that are as easy to get as possible. That means the stakes are lower, and they can run a lot more tests without worrying about wasting the eggs of endangered animals in the process. It's like your wedding rehearsal before the big event, when the endangered sperm and egg cells will be used. That way, scientists can discover what they are capable of when they approach species-saving interventions like in vitro fertilization, or IVF. So far, these dress rehearsal experiments have resulted in successful jaguar domestic cats, cow antelopes, sheep, deer, and all sorts of animals you've probably never seen before. And for clarity, you still won't see them because all the experiments mentioned in this video stopped after fertilization, so these hybrid animals did not develop further than embryos. But the fact that this works at all makes it worth investigating. Normally, you can't just add the sperm of one species to the egg of an unrelated species and end up with successful offspring, because some genes can have lethal effects when species mix. So to prevent fertilization by sperm from another species, mammalian egg cells have an outer coating called a zona pellucida. This layer of proteins acts as a kind of built-in bouncer, checking IDs to make sure only sperm of the same species can get in. For most cross-species combinations, the zona pellucida will deny entry to the foreign sperm. So to allow entry, some researchers have to take that layer of the egg off before their hybrid experiments could begin. But even bouncers aren't perfect, and neither is the zona pellucida. For some hybrid experiments, researchers found that it allowed sperm from a different species right in. Researchers think that could happen because the two species are related just closely enough to get a pass, even if they're pretty distant relatives. So knowing how sperm get past the zona pellucida is one of the first hurdles when it comes to making endangered animals in vitro. But if you're trying to figure out what about that sperm makes it viable, you might need to put it through some more extreme tests, like throwing it together with some more distantly related animals. And that is exactly what a group of researchers described in their 2015 publication. They made dolphin-cow hybrids without altering that zona pellucida on any of the eggs. They wanted to know if this could happen in the first place and how in the world dolphin sperm would fertilize cow eggs. By pairing dolphin sperm with cow eggs, they're stretching sperm outside of their usual dolphin egg encounters to see if they have the ability to fertilize eggs from another species. And it turns out dolphin sperm are so hardy that they're even more successful at attaching to cow eggs than bull sperm are, which is impressive since that's literally the one job that bull sperm have. But this does not mean that dolphin cows are poised to take over the high seas, because attaching to the egg is only the first step of the process. Even though dolphin sperm attached to the eggs more often than bull sperm did, the dolphin sperm didn't produce as many viable offspring, which shows that fertilization is about way more than a sperm getting to an egg. Ultimately, the experiment did produce some hybrid embryos, so it is possible for dolphin sperm to fertilize cow eggs. It just isn't as likely to do it as bull sperm is, which is probably for the best. But they are way more successful than anticipated, and that might have been thanks to the high quality of the sperm. These experiments probably went as well as they did because dolphin sperm swim better, have stronger chromatin, and generally hold up better than cow sperm. And whether the sperm would be viable at all after cryostorage wasn't actually a given, because other types like jaguar sperm have been damaged by cold storage in the past. But dolphin sperm are so stable that they were still viable and healthy after thawing, so all in all, dolphin sperm are pretty hardy stuff. This bodes well for the future of IVF plans, but the researchers actually didn't stop there. Once they knew it was possible for distantly related animals like dolphins and cows to hybridize, they took it a step further to test and see if even more distantly related animals like dolphins and mice could hybridize. And somehow, those combos also made successful hybrids. They might have done it less frequently than the dolphin-cow hybrids, but still, despite being less closely related and having mismatched internal structures, dolphin sperm were able to fertilize some of the mouse eggs. And this tells us that dolphin sperm might not use those internal structures the same way every time they approach fertilization. See, for an egg and a sperm to make an animal, they need some cellular structures like the centrosome, which facilitates cell division. In mice, the centrosome comes from the egg, while in dolphins and cows, it comes from the sperm. The reduced rate of dolphin mouse fertilization might have been partially due to having too many centrosomes. So by doing these tests and figuring out just how resilient these sperm are, researchers are working to keep endangered animals around in ways that most of us would not have imagined. It just goes to show that when you want to save an endangered species, you need to break a few eggs. But at least in this case, we can choose which eggs. Thanks to Brilliant for supporting this SciShow video. Brilliant is an interactive online learning platform with thousands of lessons in computer science, math, and science, including a course on quantum mechanics. Kind of like how these hybrids sort of exist in the lab, but don't really exist, quantum objects tend to toe the line of where they exist in reality. The idea that particles can be in more than one place or state at the same time is called a superposition. And you can learn all about superpositions and other quantum phenomena in the Quantum Mechanics Brilliant course. For 30 days, you can access this course for free, and after that, you can sign up for 20% off an annual premium Brilliant subscription by clicking the link in the description down below or going to brilliant.org/scishow. How much did you think you were going to learn about dolphin sperm today? Probably less than this.